Lesson 13.2, define general angles and use radian measure. Another way to think of angles besides with triangles is circular. If we have an angle in standard position, that means its vertex is on the origin, as in the picture. The initial side is on the positive x-axis, and it rotates counterclockwise until we hit the terminal side. So we have 90 degrees. So if we start here at 0, 90 would be up there. Straight across is 180. We keep going another 90 degrees. 180 plus 90 is 270. And all the way around back to where we began is 360. Coterminal angles are different angle measures but have the same terminal side. They start at the same place and have the same ending place, but they're a different measure. And you can see 3 on this picture here. The blue one would be a negative 45. The red is a positive 315. The green, went all the way around and more, is negative 405. So if you think of it as going around in circles, to get back to where it was, we'd add a full circle or subtract a full circle. So that would be adding or subtracting 360 degrees. So we take our angle and add or subtract 360 degrees, and that gives you a coterminal angle. Angle with the same ending points, but a different measure. They can be useful for solving problems. All right, draw an angle with a given measure in standard position. Then find one positive coterminal angle and one negative coterminal angle. All right, so that'd be 0, 90, 180, 270, 360. All right, 65 degrees. Well, that's between 0 and 90, and it's closer to the 90. So, there-ish. You don't need to get out a protractor, but you should be able to guess pretty close. And so our angle is that angle there. All right, to get the coterminal angle, we need to add or subtract 360. So for the positive one, maybe we should add 360. 65 plus 360 is 425. To get the negative coterminal angle, subtract 360. 65 minus 360 is negative 295. So the 425 would be starting here, go all the way around, and there it is. Negative 295 would be starting here and going backwards there. Let's try another one. Erase my marks. All right, 300 degrees. Well, 300 is between 270 and 360, and it's closer to 270. So it's like there. The angle will be starting here at the x-axis and going all the way around to there. So that's 300 degrees. To get a positive coterminal angle, add 360. So 300 plus 360 would be 660. So that would be starting here, going all the way around and back to there. So full circle plus the extra. To get the negative coterminal angle, subtract 360. So 300 minus 360 would be negative 60. It'd be something like that. Radian measure is another unit to measure angles. So we've been learning degrees. Now degrees go way, way, way back to ancient like Babylonians, Assyrians, ancient Mesopotamia, where they counted everything in a base 60. So you went up to 60 before you changed to the next unit. Like we go up to 10 to change to the next unit. We have ones, tens. They had ones, 60s, 3,600s, and so on. And degrees are based on that, so it's our time. Radian is actually more logical mathematically. It's based on a circle. The radian is the angle when the arc length equals the radius. So here's the radius. Move it down, and now it's the arc length. That angle is 1 radian. Two radians, 3 radians. So 3 radians is almost half a circle. They're actually pi radians in half of a circle. 2 pi radians then would be in the full circle. So again, 1 radian is when the arc length equals the radius. There are approximately 6 in a full circle. It's technically 2 pi, which is 6.28. Pi, remember, is just a number, 3.14. There are 2 pi radians in a full circle. To convert between degrees and radians, use the fact that 180 degrees equals pi radians. Our special angles, then, are there. You need to memorize that chart. If we're doing regular school, I'd have a quiz over this where you'd have to draw it from memory. Convert the degree measure to the radians or radian measure to degrees. So 135 degrees. Well, we're going to use the fact that pi radians is 180 degrees. All right, so I'd put it this way so that the degrees cancel out, just like you convert units. I mean, they are just units. So it's 135 pi over 180. 135 over 180 reduces to 3/4. So it's 3 pi over 4. Pi is not the unit of radians. Radians is the unit of radians. Pi is just a number. 3 pi over 4 radians. How about negative 50 degrees? Again, I'll multiply by pi, I'll divide by the 180 degrees so that the degrees cancel out. So the degrees cancel out. So it's negative 50 pi over 180, which reduces to negative 5 pi over 18. Let's convert the other way. This one's radians. How do I know? Because there's no degree sign. If it's in degrees, it'll have a degree sign. If it does not have a degree sign, then it is radians. All right. Typically, though, if there's a pi, you want to convert it to degrees. We want the pi to go away, so I'll have pi on the bottom. That way the pi's cancel out, and I'm left with degrees. So I'll have 5 times 180 divided by 4 is 225 degrees. How about changing pi over 10? Again, I want the pi to cancel out, and I end up with degrees, so I want that on top. So I'll be timesing it by 180 degrees over pi. The pi's will cancel out, and I have 180 degrees over 10, which is 18 degrees. A sector is a slice of a circle, like a piece of pizza. The arc length is part of a circle. To find the arc length, it's S equals the radius times the central angle. The arc length is S, R is the radius, theta is the central angle. However, the angle must be in radians. If you remember in geometry, we multiplied by the arc length over the the arc measure divided by 360 times 2 pi r. All that did was converted the degrees to radians. So for Radian radians, it's just radius times the angle. The area of a sector is 1/2 r squared times the angle. But again, our angle must be in radians. All right, here's a baseball field. Find the length of the outfield fence if it's 220 feet from home plate. Well, that would be an arc length. The outfield fence looks like part of a circle, so it's an arc length. So Our angle has to be in radians. Here we're given as 90 degrees. Well, I need to convert 90 degrees to radians. It's on that circle you should memorize with all those angles. But 90 degrees, pi over 180 degrees. So that gives us pi over 2. So our angle is pi over 2. All right, arc length is S equals r theta. The radius is 220 feet. Angle is pi over 2. So that appears to be 110 pi feet, or approximately 346 feet. Why would I use the decimal there? Because it's a word problem. Find the area of the baseball field. Well, that's a sector of a circle. It's a piece of the circle. So area of a sector, 1/2 r squared theta. R is the 220 feet. Theta is pi over 2. Multiply it together, you get 120 or 12,100 pi, or 38,013 feet squared. Again, I found the decimal because it is a word problem.